All right, we're going to talk about geometric series, but everything that we were talking about before was talking about finite geometric sequences, where you had a set number of terms, but your sequence ended. There are geometric series that go on and on and on forever. They are infinite, and there are some of those series that we can actually find the sum of that series, and then there's some of them that we can't. So we need to talk about which one of the ones that we can and which that we can't find. If you haven't watched the YouTube videos listed on your packet, watch those first because it talks about the different types of infinite series and it gives a really nice visual. But if you have, then let's go ahead and fill out these notes. So first of all, just the basics. How can you tell if a series is infinite or finite? We're going to be looking at how the series is written. So a finite geometric series is going to be written like this, and it's going to end with the last term. An infinite geometric series has no last term. It keeps going on and on forever. So it's going just to end with a plus and then a dot, dot, dot to show that it's going on and on forever. So the two different types of infinite geometric series is diverging and converging, and hopefully you should have watched the video talking about them. A diverging series is when each term is being multiplied by the absolute value that's bigger than 1. So basically the series is getting bigger and bigger. The terms are getting larger and larger and larger and larger. The absolute value of the terms are getting larger and larger and larger. Or, I mean, technically they could be getting smaller and smaller, you know, but the absolute value is increasing. And basically, if we were to find the sum, that sum would either approach positive infinity because they're getting so large, or it's approaching negative infinity because they're going so much in the other way on that number line. A converging series is the one that we're going to be dealing with. We're multiplying by the ratio, and the absolute value of the ratio is less than 1. And because of that, each term kind of gets smaller and smaller and smaller, and so, you know, the term is like infinitesimally small, and so therefore the sum approaches a limit. So diverging series, we cannot find the sum. The sum is approaching infinity. Converging series, we can. So let's see, a geometric series converges when the absolute value of the ratio is less than 1. And that just means that the ratio has to be smaller than 1, but bigger than -1. Why is this? We're multiplying each term by a number that's smaller than 1. And so each term is going to get smaller and smaller and smaller and smaller and smaller and smaller, tiny little terms, until eventually they're so infinitesimally small that they really don't matter anymore. And then, can we find the sum of a diverging series? Why or why not? We can't. There's no way to do it because the sum is getting infinitely large or infinitely small, meaning it's approaching positive infinity or negative infinity. So we can only do converging series. So the first thing you need to know how to do is, first of all, identify, is this geometric series converging or diverging? If it's diverging, we can't find the sum. If it's converging, we can find the sum. So let's go ahead and talk about how we can find the sum. So the formula for the sum of an infinite geometric series, and it has a first term of A and a common ratio of R, where the absolute value of the ratio has to be less than 1, is this. The sum is the first term divided by 1 minus the ratio. Super easy. This is wonderful, easy formula. So let's go ahead and practice. We're given the first term and the common ratio of a geometric series. We have to determine, does it converge or diverge? If it diverges, we can't find the sum, but if it converges, we need to find the sum. So let's do example 4. Let's see, the first term is A and the ratio is 0.5. So I'm going to take a look at the ratio. Is the absolute value of 0.5 less than 1? It is. So this converges, which means we can find the sum. The sum is A divided by 1 minus R. The first term is 16. The ratio is 0.5. So 16 minus or divided by 0.5 is 32. So the sum of this infinite geometric series that starts with 16 is 32. Now, what this technically means is this means that the sum approaches 32, but it never actually reaches 32. But it gets so stinking close to 32 that for all practical purposes, we just say, yeah, the sum is 32. So here's what's happening with this particular one. If I'm multiplying by 0.5, I'm dividing by 2. So my first term is 16. My second term is 16 divided by 2, which is 8. My third term is 4. My fourth term is 2. My fifth term is 1. Okay, those are all adding to my sum. My sixth term is a half. My seventh term is 0.25. Now you see what I'm adding to the sum is getting smaller and smaller and smaller. Okay, then I'm getting really small numbers here. If I keep going, and honestly, I mean, this is infinite, so I can keep going forever and ever and ever and ever and ever. But you see, oh, I cleared it off somehow. But the numbers after we get so far in our series, the numbers get so stinking tiny that they really don't influence the sum at all. So for all practical purposes, we say that the sum is 32, but just keep in mind that's a limit. It means it's approaching 32 and it gets super close to 32, but it never actually touches or reaches 32. All right, example 5. Our first term is 3, our ratio is 2. So can we find the sum? I take a look at my ratio. The absolute value of 2 is not less than 1. This series diverges, which means all of the terms are going to get bigger and bigger and bigger and bigger. So I cannot find the sum. Can't find the sum. It's going to approach infinity. And what this is looking at, my first term is 3. My second term is being multiplied by 2, so that's 6. My next term is 12. My next term is 24. And then if I continue this series on forever and ever, each term is going to get super large. So it's just going to be an infinite amount. Go ahead and work on numbers 13 through 16. Figure out if it's converging or diverging. And if it converges, you can find the sum. And then come back and check your answers. Sum. Let's go ahead and do some tad more complicated problems on the next page. For number 17 and 18, determine if it's if it converges or diverges, and then find the sum. So with this one, my first term is 1, and then my ratio is, what's happening to each of these terms? 1 to 0.6 to 0.36. Well, I realize I'm multiplying by 0.6. The absolute value of 0.6 is less than 1, so it converges, so I can find the sum. The sum is that. So I have 1 over 1 minus 0.6, which is 1 over 0.4, which on my calculator is 2.5. Nice. All right, second one. My first term is 4/5. I do realize it's going on forever. It's infinite. So I have to figure out what is my ratio. Let's see, 4/5 to 2/5 to 1/5 to 1/10. I already can tell this is converging because each term is getting smaller, like closer to 0. So let's see, how do I get from 4/5 to 2/5 to 1/5 to 1/10? Oh, I can take a look here. 1/5 to 1/10. 1/10 to 1/20 is being multiplied by a half. So my ratio is a half. So my sum, let's see, is 4/5 divided by 1 minus 1/2. That's 4/5 divided by 1/2. And dividing by a fraction is the same thing as multiplying by the reciprocal. So that sum is 8/5. All right, let's go ahead and do number 19. What is the first term of an infinite geometric series if the sum and the common ratio are 35 and 0.6 respectively? Well, obviously, if I can find the sum of the infinite geometric series, that means it is converging. So let's write down what we know. I don't know the first term. I do know that the sum is 35 and the ratio is 0.6. So let's just write down our formula and plug in what we know. The sum is 35. I don't know A. I'll go up here. Gonna multiply by 0.4. 35 times 0.4 is 14. My first term is 14. Go ahead and try number 20. So you find the common ratio of an infinite geometric series if the sum and first term. So I'm going to again write down what I know. Don't know the ratio. I do know that the sum is 1/33 and the first term is 19. So again, I'm just going to write my formula. I know it's converging because I can find what the sum is. So I better get the absolute value of r to be less than 1. The sum is 1/33 equals 19 over 1 minus r. I am going to cross multiply here. 133 times 1 minus r is 19 times 2. We'll use our distributive property. 19 times 2 is 38. I'm going to subtract 133. I get negative 133r equals negative 95. My ratio is 95 over 133. I do believe I should be able to simplify this. And let's see, 95, I divide this by 19, I get 5/7. So my ratio is 5/7. And that confirms the fact that the absolute value of this should be less than 1, which indeed it is. Hopefully, we are okay on finding the sum of an infinite geometric series, assuming that it converges.